Okay. We're looking at chapter 6 now, which is joining tables in a relational database. And basically, a relational database is an application that supports data stored across multiple related tables. In a relational model, each table typically holds data on one entity. And each row in the table describes one of those entities. A process known as table join allows us to link rows in one table to rows in other tables. So we're going to use join. To connect tables in a query, we use join on, we use a join on statement or one of the other join variants. So will you do the first one? Select that. Let's see it. Yeah, have you inserted those values? I'm sure already. Oh, there we go. Yeah. So now it's joined them, as you can see. It's joined the two tables.
Yeah, the query return successful, and then we use the join.
Okay, great. Oh no, it's done. It's whatever. It's fine. So this is similar to the basic select syntax we've learnt already, but instead of naming one table in the from clause, we name a table, give the join keyword, and then name a second table. The on keyword follows, where we specify the columns we want to use to match values. When the query runs, it examines both tables and then returns columns from both tables where the values match in the columns specified in the on clause. So we're matching based on equality between values is the most common use of the on clause. Okay, relating tables with key values. Consider, so what's happened is we've been given a huge dump of data from the payroll system, which is a dozen CSV files, which represents one table in the database. And we read the document explaining the data layout and to start to make sense of the columns in each table. And so two of these tables stand out, employees and departments. So we're going to create versions of these tables, insert rows, and examine how to join the data in both tables. So using the analysis database, again, the big one that we've got, and we've already, so go to your department, it should be there, yeah, you're there. It's been created, that's what we're doing here, and we've got basically the ID, which we've made it a big serial. We have the department name, a variable character, and the city, and all of that. Let's see yours. Which one is this? This is listing 6.1 actually. I know we've already inserted all of that, and then we went past.
Yeah, so now if you do 6.4 doing the join, then we can see here where once you use a join, then it takes the two, how they set it up as left and right school. Now they've joined them.
Okay, great. So that's done that.
Yeah, okay. We can try for an inner join. Then if you do a left join, adds a few more of them. And then obviously then if you do the right join, you'd have it do it the other way around. So then it just takes the values from each side, whichever side you've specified.
Yes. Brilliant. So yeah, that basically summarizes everything that's above there, is that we've got all this data and there's different ways to join them, and these are some of the methods that we use. So we use join or inner join when we want to return rows that have a match in the columns we used for the join. Okay, we've done that. We've done left join and right join. Let's just see if there's any other info that we can just touch on. So in contrast to join the left join and right join, each return all rows from one table and display blank rows from the other table if no matching values are found in the joined columns.
Which we see over here, where it says null. And then the same then you would have then with the
right join.
The right join, and then this one that I've run now is the same, but this is the outer.
Okay, so full outer join is when we want to see all rows from both tables in a join regardless of whether any match. Use the full outer join option, yeah.
Yeah, so they're like Washington obviously doesn't have a match, nor do these two on the side.
Great.
So that all happy days.
So then there's something, don't do it, it's called a cross join. Oh no, it won't be bad. Lines up each row in the left table with each row in the right table.
So let's try that.
Because the join doesn't need to find matches between key fields, there's no need to provide the clause using the on keyword. So it has 20 rows, the product of 4 rows in the left table times 5 rows in the right. So unless we want to take an extra long coffee break, avoid a cross join query on large tables.
Yeah, can you imagine? If you look at this.
Yeah.
That's on a small one.
Yeah. So then we can even use null to find rows with missing values. And that helps us find where there's missing values.
So yeah, we can check that.
So null represents a condition in which there's no data present or when the data is unknown because it wasn't included.
So that in that example, we have the Washington
The
middle.
where, yeah. Where ID is null, basically. From the left join right, where they equal each other, where schools is null. There we go, so it's missing it from the right, as you say. So there's 3 types of table relationships. A one-to-one relationship. One-to-many and a many-to-many relationship. But these are all parts of tables and how data is structured, which is the database's relational model. It's a one-to-one relationship when there are no duplicate ID values in either table. In a one-to-many relationship, a key value in the first table will have multiple matching values in the second table's joined column. Okay, that makes sense. Many-to-many, multiple rows in the first table will have multiple matching rows in the second table. So we can also select specific columns in a join. So far we've used the asterisk wildcard. That's okay for quick data checks, but we might want to see specific subset of columns. So we can use the select keyword followed by the desired column names. When joining tables, the syntax changes slightly. You must include the column as well as its table name. So we say select ID from schools left join schools right. Yeah, that one, 6.10. So just run that for us.
There it is there. So there we have as per their one.
Okay.
Oak School, Roosevelt, Washington middle, there's no match on the right. And then Jefferson as per their goodie.
Great. And we can also add the as keyword with census data to make it clear in the results that the ID column is from schools left. The syntax would look like that, but we haven't got that. That's the one.
Yeah, but yeah.
Okay,
yeah,
let's go to the next one, 6.12. Well, and 6.11. Have we done that? Yes.
Yeah.
That is just simplifying the join syntax with table aliases. So naming the table is easy enough. Naming the table for a column is easy enough, but doing so for multiple columns clutters the code. And one of the best things we can do is write readable code. And so we can use a shorthand approach called table aliases. So we place a character or two after the table name when we declare it in the from clause. Can use more than a couple of characters for an alias, but if the goal is to simplify code, don't go overboard. And so those characters serve as an alias. And those are the aliases that we've used there. And you've run it already. Joining multiple tables. And SQL joins aren't limited to 2 tables. We can continue adding tables to the query as long as we have columns with matching values to join on. So let's say we obtain 2 more school-related tables and want to join them to schools left in a 3-table join. Here are the tables. School enrollment has the number of students per school. Okay. And we have their grades. So we'll use 612 to create the tables and load the data.
Yeah, so yeah, if you run these here, all they're doing is inserting all the data.
Yeah.
And then once you're done and then you run, then it'll return left school, the name, the amount of enrollment, and then the grades.
Great.
So we're asking it for the left school, the enrollment and their grades. And then it gives you their ID as well.
Nice. So those are the results as you've shown. And we can even use aliases as well. And then we can even, last part of this chapter actually is performing maths on joined table columns. And we did the maths earlier. We could do loads of maths. We didn't do it as part of our course, but we understand some basic maths and we know some basic programming already, so we know that these things can do all sorts of maths, and I'm sure that's very useful for data collection. So here let's just run 613. Here we're creating the table with all our info. We're going to copy it. Oh, so yours, will it work though, because you haven't gotten copy US counties?
That works.
That one
there.
No, you have to do the copy first, yeah?
That will be...
Oh, error. Damn. Hang on. You have to just change the directory. It might work.
You see there, it runs. It pulls...
Oh, okay. Gosh. Maybe it worked. I remember it worked previously, so it's probably done it already. Yeah. Okay, great. Well, it works.
It might be because it maybe, I don't know, maybe it's because it's there already, I don't know. But it is working. So.
Cool. Okay, great. So we did that, we copied it, we're selecting which ones we want to do stuff on, we're rounding up, we can do minuses and times, percentage change things that we can see. Then we're doing an inner join. And then we're getting loads of more data from it. That's what that is saying, and we're using our shorthand, what was it called, aliases, yeah? Great, so that gives us those results there. Wow, so cool. Great, thanks Dom. So basically wrapping up, we can join tables, we can do all sorts of things with our tables and make it more readable, and we can do maths on that then. And now we will be going on to bigger concepts, into finding information in data sets and working with the finer nuances of handling data types and making sure we have quality data. Alright, so that is chapter 6, I think. Is it 6?
Yep.
Yeah, great, thanks. Stopping recording.